let's talk about 3-4, solving systems of linear equations in 3 variables. Okay, so we talked about, I think in 3.2, solving with 2 variables with an x and a y. We're going to throw a z in there, okay? Because when we graph things, you're used to graphing on the x, y axes. There's also a z axis, which is for 3-dimensional things. Because you can graph 3-dimensional things. So we're going to kind of throw that in there slowly as we go about this year. So, what? There's not.
But wouldn't there be one, like, if you have like a 3D graph, so then you'd have like the y, the x, the z.
And what other letter would it be?
No.
The
Okay.
other one, no, because it could go through.
So linear equations in 3 variables, x, y, and z is an equation of the form of ax plus by plus cz equals d, where a, b, and c are not all 0. Okay? The following is an example of a system of 3 linear equations. 2x plus y minus z equals 5, 3x minus 2y plus z equals 16, 4x plus 3y minus 5z equals 3. So just 3 equations in order. A solution of such a system is an ordered triplet. When you write an ordered triplet, it is written x, y, z. So when you're writing your answers on your homework tonight, you're going to have an ordered triplet, and it is in the form x, y, z. Okay? So you're just adding that 3rd answer to the end. Yes?
Very serious question.
Okay.
So z goes like that, right? That.
Yes.
So.
That's the way we represent it.
Is there 2 z's?
Mm-hmm.
Okay. I didn't know.
Okay? And those coordinates make each equation true. So just like when we had solving for 2 variables where we had no solution or we had infinite solutions, we also can have that in this case too. Okay? The graph of a linear equation in 3 variables is a plane in 3-dimensional space. The graphs of 3 such equations that form a system are 3 planes whose intersection determines the number of solutions of the system as shown in this diagram that we're going to look at next. Last year when you guys took geometry, you talked about when planes intersect, what do they create?
Oh.
They create line. They create a line. The intersection of 2 planes is a line. The intersection of 2 lines is a. I'm going backwards now. If 2 lines intersect, what do they create? A specific
intersection.
Right, and that's called a
right triangle.
Right. Cube.
Right angle.
If this line
Plane. Oh, I think
intersects with this line,
A 90-degree angle.
what is this right there?
Vertex. Point.
A point.
Oh.
It's a point. So when 2 lines intersect, they form a point. When 2 planes intersect, they form a line. Okay? So what we're looking for here for this ordered triple is where on that line do all 3 of them cross?
Can you draw 2 planes intersecting so I can have a visual?
Yeah, I'm going to give you one.
Oh,
Okay.
that's not confusing at all.
Not at all. So this is an example of exactly one solution. 3 planes intersecting in a single point. The red, the green, and the blue are all intersecting at that central point right there. Okay? It'd be like if I took 3 pieces of paper and had them intersect. If I can do this, I don't know if I can do this. Okay. So it would be like taking 3 pieces of paper and having them intersect. Works a little bit better when you have cards. Okay. So when I have 2 that intersect, it creates this like one little line where they intersect. Yes? Line. Okay? When you have 3 that intersect, oh, I can't hold up all 3. This is the problem.
This is so tricky.
It is tricky, sorry. When you have 3 intersect, they're going to create this specific point right there in the center of them, like right here. Okay? And so that's exactly one solution. If you have infinite solutions, okay, the planes are all going to intersect on each other. Okay? No solutions can be a number of ways. All the planes could be parallel to each other. One plane could intersect the other two, but not all three planes intersecting. So all three have to intersect for there to be a solution.
So for infinite and many solutions, like, so it's kind of like a star, where like they all kind of like. one point.
Yeah. And we're going to do the math, we're going to do the algebra behind it so that you can see it better. The algebra makes it make sense, because when you go and do the algebra behind it, you get like a number, right? Like 6 equals x, or 6 equals 0, which means I have no solution, or things like that. So you'll be able to visualize it better algebraically than visually, I think, okay? So when you have solutions, you can have an infinite solution, exactly one solution, or no solutions. Okay, so we're going to take this the same way we took the other ones. You're going to rewrite, for step 1, you're going to rewrite the linear systems in 3 variables as a linear system in 2 variables by using the elimination method. So I'm going to take 2 of the 3 equations, eliminate an x or y or a z out of it, and then I'm going to have to keep subbing back until I get down to 1 variable. You're going to solve, you're going to substitute. We're going to go over it. Okay, so I have 3 equations here. First one is 4x plus 2y plus 3z equals 1. Next one is 2x minus 3y plus 5z equals 14. And the last one is 6x minus y plus 4z equals -1. Okay. If you look at those 3 equations, you want to start by asking yourself, is there any way that I can combine 2 of them to get rid of an x, a y, or a z? Any simple solution that I could do? Like, do any of them cancel out right away? No. But, okay, I see that this y has nothing in front of it. It has a 1. So, I know that if I can multiply that equation by something, I can cancel out my y's, okay? So if I were you, I would take equation 1 and rewrite it. 4x plus 2y plus 3z equals 1. Okay, and when you rewrite that, then I would come down here to the last equation, and what would I multiply this last equation by? 2. Okay? I'm going to multiply this by 2 so that I get 12x minus 2y plus 8z equals -2. Now I can solve this. Okay? I'm going to simply add these together. What is 4x plus 12x? 16x. So I get 16x, okay? The y's canceled. What's 3x or 3z plus 8z? What? 11z. And then what is 1 plus -2? Okay. We're going to pause there for a minute, okay? We're going to come back to that equation because now I have it down to 2 variables. So I'm going to come back up here, and I'm going to say, oh, now I need to do something to this equation so that this will eliminate this y.
Why'd you write it in green?
Okay, I always switch colors for every equation because that's how my mind works. And
Well, I mean,
can
like
see.
the 16, so you added the green one and the red one, but then why is the outcome green?
I just wrote it in green because
Okay,
that's what I
then
chose.
okay.
What is green and
Because
red?
I'm colorblind, I just want to make sure I'm not like.
No, you're fine. And so now I'm going to take this equation, the blue equation, and I'm going to say 2x minus 3y plus 5z equals -14. Okay? What are you now going to multiply this red one by? I can multiply it by, okay, so this is a negative and that's a negative, so what do you think you should multiply by? -3, so that it will change to a positive. So now I'm going to multiply it by -3. -3 times 6 is -18, right? -3 times a positive, or -1 gives me a positive 3y. -3 times 4 gives me -12z. And negative 3 times negative 1 gives me a positive 3. Now I'm going to add these together. Okay. 2x minus 18x gives me what? Negative 16. Negative 3y plus 3y cancels. 5z minus 12z gives me negative 7z. And negative 14 plus 3 gives me, okay. Now, do you see that I have two equations with just an x and a z in them now? Okay. So now what do you think I'm going to do?
You can cancel the 16x and the negative 16x.
Yes. So I'm going to rewrite this over here under here so that I can add them together. And then I'm going to add, I'm going to add these together. So the negative 16 and the 16 cancel. What's 11 minus 7? 4? Yeah. So 4z equals, and what's negative, okay, negative 12, good Tyler, and then 3. Yes. Now, what do you think I'm going to do with this z?
Plug it in.
Plug it back in. I'm going to just plug it over here because I have more room to work over here. It doesn't matter which of those two
Negative 16x
equations.
plus 21.
I'm going to plug it in here so that it says negative 16x minus 7 times negative 3 equals negative 11. Negative 16x plus 21 equals negative 11. Subtract 21.
10. Oh, wait.
Negative 16x equals negative 32.
Wait, I thought if you subtracted a negative from a negative, it's like subtracting
A negative times a negative is a positive. When you subtract a negative from a negative, you already get that. Okay, so negative 16. So then x would equal, what's negative 32 divided by negative 16? 2. Now what do you think I'm going to do with x and z?
Plug them both in.
Plug both of them back into one of the original equations. Okay, one of the originals. It does take
Please don't
forever.
give us a worksheet of 24 problems with these.
I won't give you 24, but this does take forever. I know. So now I'm going to come up and I'm just going to choose, it doesn't matter, I'm just going to choose the top one, okay? And I'm going to say 4,
You have an iPhone X?
yes, times 2.
She got the jams out.
Is it negative? Oh, okay. Oh, you made me nervous for a
I
second.
wish I had racks like that.
Plus 2
Yeah, you can work
y
it out in school, you can-
plus 3 times, what's my z, negative 3 equals 1. Sorry, I'm kind of writing over top of this other equation, my bad. Okay. So 4 times 2 is 8 plus 2y plus 9 equals 1.
Would it be minus 9 because?
Oh, minus 9, yes. I thought it was a double negative for some reason. Minus 9 equals 1. So then I get 2y minus 1 equals 1. So I get 2y equals 2, and I divide by 2, and you get y equals 1. So your solution is x,
1.
y, z.
That is so weird, bro.
X, Y, Z.
See,
X,
imagine
Y,
if there was
Z.
a fourth dimension, bro.
Okay.
Then it'd be lighter.
Is that difficult?
I would-
Not really. Does it take a lot of time? Yes. If you mess up one little thing, it's gonna mess the whole problem up.
Okay, so if we were to do this on a quiz test and we got one little thing wrong.
Then I would just grade from there if you got everything else right. Like you just missed partial point for
Miss
that.
Peters, there could be a fourth dimension.
Tyler, stop.
Okay?
No, there is a fourth
Here's
dimension.
another one. Look at this one. This one has x plus y plus z equals 3, 4x plus 4y plus, oh, they made this one so easy. This is beautiful. We love this one.
Easy.
Maybe you do.
Yes.
That's,
Oops, maybe I got
That, with that last.
oh, because
that,
there's two Y's.
that last problem literally took up half a page.
yes.
Right.
And that's what's gonna happen on this homework.
Bruh.
Fantastic.
That is not good for the environment.
Okay, look at this this one. Why do I say that this is a beautiful problem?
Because
you're
there's
a
two
strange
Y's.
person.
Because the first whole equation has only ones in front of it, so I can do whatever the heck I want. And the second equation has all fours. So what do you think I'm going to multiply the top one by?
-4. Or, yeah.
By -4. Yes, good Brady, by -4. So if I take this and it's because my board is too high. Shoot. Okay, I'm going to multiply it by -4. So I'm going to get -4x minus 4y minus 4z equals -12, yes? And then I have 4x plus 4y plus 4z equals 7. And I'm going to add these together. So you're going to get 0 plus 0 plus 0 equals -5. Does 0 equal -5?
No, no
So-
solution. That's a beautiful.
He's like, please let that be 90% of it.
Yes.
Okay? So if you see something like that, jump on it because it makes it easy and you don't have to do a lot.
Get on.
Okay, so there are no solution ones. And these no solution ones are sometimes easier to pick out because stuff will be obvious like that. So go for it. Make it easy on your life.
Jump.
Okay, what about this one? How can I solve this?
You're gonna multiply the first two ones.
I don't even need to multiply the first two yet. Why do I not need to multiply the first two?
Because you
Oh,
cancel
they
those
eliminate
numbers.
each other.
Because the z's automatically will eliminate each other, yes?
Yes,
Because one's positive and one's negative. So if I say
actually.
x plus y plus z equals 4, and I say x plus y minus z equals 4, okay? I'm going to go ahead and add these together. So you end up getting 2x plus 2y equals 0, okay?
So isn't it still no solution?
Not yet.
Oh God.
Okay, now, if I'm going to multiply the green or the, or I don't even have to multiply any of them at this point. What can I do with the blue and red now? What will automatically happen?
I don't get it. When they all cancel out?
Look, this is a negative z, positive z. So I don't even have to multiply this one, which saves me so much more time. 3x plus 3y plus z equals 12. You're going to add these.
Miss Peters,
Yes.
you do realize 4 plus 4 is 8, right?
I was thinking they're negative, thank you.
What's the title of this?
What?
What's the title?
No, no.
No, sorry, it's
Yes,
continuous.
3
Hey, bro,
variables.
you gave for that. Just like Alex.
Now what do I do here?
In 3
What's x and 3x?
4x.
4x. What is, y and 3y?
linear
What is-
in 3
Nothing.
variables.
And what is 4 and 12?
16.
Oh, this is beautiful. Why is this beautiful?
I have no idea.
You can add them.
Oh, you can
green and
multiply it
blue.
by
What do I need to multiply this
Negative
by?
2.
Oh, just kidding.
Can we slow
By
down?
negative two.
Cameron doesn't even have one of them written down.
Yeah, I'm just writing down the very first equations. Equation 1, 2, and 3. I'm so serious.
So now I have it at 4x plus 4y equals 16, and the other one is 2x plus 2y equals 8.
Okay.
For an x or for a y to cancel out, I need to multiply the green one by
Negative.
-2. Okay, which means I'm gonna get -4x minus 4y minus 16.
0.
You're good.
Awesome.
See, so it is no solution.
No, it's not
Ain't
no
gonna be able to
solution.
try. Infinitely many
Kill
solutions.
himself.
I sent about a commission to that.
It's okay.
He ain't even here. That's why I'm
That's
saying
why.
Where is Austin?
golfing.
Austin.
Him and Derek. Derek.
He both dad.
Oh,
Okay.
they have a game.
That is exactly what your
Someone
homework is
just sent
over
Austin a
tonight.
picture of
It's
our
Peters.
Or else I'm about to
We send them like an entire page with